when we're factoring, some things we need to look out for are some patterns. And we've already talked about perfect squares having a pattern. And we've already talked about the difference of two squares. It's when we have a sum and difference. Or these are also called conjugates. Conjugates are when you have one that's being added and one that's being subtracted. Same thing. So let's see what we would get if we had a squared plus 6a plus 9. Does this match any of our patterns? So that we don't have to worry about the whole box and all that stuff. Well, that's something squared. That's twice something that's squared here. Yeah, a plus 3 times a plus 3. Or a plus 3 squared. What about s squared minus 8s plus 16? Ooh, that's a perfect square. That's a perfect square. It's got subtraction. I wonder if the square root of 16 is 4. Is that doubled? Sure is. That'd be s minus 4, s minus 4, or s minus 4 squared. Let's look at the next one. 16h squared minus 25. Is 16h squared a perfect square? It is. Is 25 a perfect square? Do we have the difference of two squares? We do. That would have to be 4h plus 5 and 4h minus 5. That's the only way we're not going to have a middle term there. All right, let's look at a harder one. 9x squared plus 42x plus 49. Oh my gosh, that's really ugly. But I notice this is a perfect square, and this is a perfect square. So a good try would be go for 3x plus 7 times 3x plus 7. Let's see if that works. When I multiply that out, let's see what those other terms are going to be. This one need a little bit more room, right? Okay. 3x times 3x is 9x squared, so we got the first term right. 3x times 7 is 21x. 21x and 49. Does 21x plus 21x give us 42? Sure does. So that's always a good try there. Now, there's one more special pattern, and it has to do with cubes. So let's look at that for a second. There is one called the difference of cubes, and we have one called the sum of cubes. So let's look at the difference of cubes first. The difference of cubes says that if I have a cubed minus b cubed, it will factor into a minus b times a squared plus ab plus b squared. So let's look at an example so we can see how that would work. If I had x cubed minus 27, okay, x cubed, that's definitely cubed. What cubed would give me 27? Oh, that would be 3 cubed, wouldn't it? So this would give me x minus 3. 3 cubed, that's the 3. So 3 is going in for b, and the x is going where the a's are. So a squared would become x squared plus, very important, this is a plus, the a times the b. So x times 3, or 3x, plus b squared. Well, the b was the 3, so that gives me a 9. And just a note here, what we come up with, this trinomial is always going to be prime. It's not going to factor anymore, so you're going to be done, which is nice. Now, there's also the sum of cubes. It's when we have a cubed plus b cubed. And it has a special pattern also that it factors into. Factors into a plus b. Over here, it's going to be a squared minus ab plus b squared. The reason we have to have opposite signs here is so that the middle terms all cancel out.